All right, section 6.5, trapezoids and kites.
That's nice.
I don't think I've mentioned this yet, but I really do like this chapter because it's just fun. It's organized. Okay,
You like a lot
so
of chapters,
I
so-
do. I know. But I love geometry. What can I say? Okay, an isosceles trapezoid. So let's draw a nice trapezoid where the base angles that we've talked about this before, do the best you can at making them congruent. I don't know if I can cut this here. Oh, nope, it doesn't let me cut it. Nope, not what I want to do either. Okay, so in an isosceles trapezoid, the things that we have that are key points are these things here. This and this are congruent base angles. There and there. And the top ones, oddly, are also called base angles. Mainly because you can flip to the other side. So these are your base angles here. And then on the sides, we call those legs. Here, kind of like an isosceles triangle. So imagine this with me. If I have an isosceles triangle like this, where the legs, we call those legs also, right? They're congruent just like they are in the isosceles triangle, or isosceles trapezoid. The base angles are congruent. So imagine cutting this right here down the center and then kind of pulling them apart that way and that way. If you cut the triangle down the center and you pull it apart and connect it with a line in between here and here, you end up with an isosceles trapezoid then. Does that make sense? So that hopefully you can see, what's that?
Wait, what are you connecting now?
So if I were to take this triangle, this red triangle here, and I cut along this purple dotted line, I would have two triangles, right?
Yeah.
A triangle that looks, let me slide this up a little bit, like this. It would be a right triangle technically, right? And like this, that's where I would slide it apart to be, so that, I didn't draw it very, very well. Hold on, let me try that again. So I'd have this, trying to make them congruent triangles. And we've proved in the previous chapter that if I have an isosceles triangle and I have that line cut down the middle, like up here, this one, I would have a right angle on both of them. And because of this, I would have this side is congruent to itself. This and this are congruent to themselves, right? Because it's an isosceles trapezoid. And you have an angle and you have right angles there. So you have two congruent triangles. A couple ways you could have done it would have been, what was it? Hypotenuse leg, because it's right triangles, right? Your hypotenuse and your legs are congruent. So these two, this triangle and this triangle are congruent. So over on my lower one that's neater, I would have congruent angles there. CPCTC would say that those angles are congruent, right? So if you imagine taking and then connecting here and here, you have an isosceles trapezoid. It's not a very long one.
Connecting it like that.
Yeah.
Not sliding together. I'm like, that's just
No, sliding it apart and then making the line to connect the tops and the bottoms. You now have, if I were to highlight it, this. Yeah, you have a quadrilateral now. That's a nice isosceles trapezoid. And hopefully it makes sense then that the top angle, let's see if I can put something in here. There is a right angle and there is a right angle. So a right angle plus congruent parts is going to make it so that this entire angle up here is congruent to this entire angle up here. Does that make sense? There's no theorems about this. It's more just like understand where an isosceles triangle is coming from and how you can use it, what you can know about it, that sort of stuff, right? So inside of like this little part in here where there's a heart, that's technically a rectangle. There's 4 right angles in there. There's opposite sides that are parallel and congruent, right? Because you slid the 2 triangles apart the same distance. So there's just some interesting things that you can note about how you might form an isosceles triangle so that you can use this information later. Okay, so from there, now that we have all those things labeled, we can talk about a theorem finally. The base angles of an isosceles trapezoid are congruent. That's actually a theorem. The base angles of an isosceles trapezoid are congruent. So if you want to give yourself a quick sketch, just to say what we're talking about, and remember that the base angles are the top and the bottom. So the bottom ones are congruent to each other, the top ones are congruent to each other. I am not saying the bottom and the top are congruent. Do you see how I made sure I put two arcs in either the top or the bottom? One arc in the opposite. Okay? All right, so let's try this. So let's do an example. Example 1. A, B, C, D is an isosceles trapezoid. So the directions tell you some information. And then measure of angle B is 102. So I'm going to draw it then. So here, 102 is pretty darn close to 90 as far as how you're sketching this. Something like this, right? And then we'll say this is A, B, C, D. And then we can say that this is 102 in here, 102 degrees. And remember that the top and the bottom of the trapezoid are parallel to each other, right?
Mm-hmm.
So, yeah.
Is this its complementary angle?
To which
B.
one? Yeah. Hannah's asking if angle A down here is complementary to there. So quick, like, let me highlight some things in here, literally with the highlighter. If I'm looking at this line and this line that are parallel, right? This line AB is a transversal, isn't it?
Mm-hmm.
So there's some characteristics of parallel lines and transversal
So
that we remember.
on the outside of A, like on the other side is 102. So then you take away 102.
Yeah, so Lily's saying like over here, I think, is what you're talking about?
Yeah.
There and there are congruent.
Mm-hmm.
Right, so then here and here are congruent.
Yeah.
So this one out here,
So then A would be.
right, so all across here
So you do 180.
is
take away
180.
102.
What's that?
You do 180, take away 102.
Right,
Because
so
78.
I didn't finish the whole, like, yeah, we're supposed to find the measures of all the angles in here, right?
Oh, yeah.
So that was the
Read
part of the
that.
question, sorry. Find the measures of angle A, B, and D, or sorry, A, C, and D. So we
Okay.
need to find them. So
So that's 102, and then both of these two are the same.
wait, hold on, Lily, how did you find the one down there? What did you say?
So like the opposite interior angles are equal. to
They're
each
not
other.
opposite interior.
Oh, wait.
They're same side
Yeah, same
interior.
side, that's what I was saying.
Okay, so I'm going to write that down as a quick note. Same side interior angles are supplementary. Sorry, like really messy there.
Is that a theorem or something?
It is a theorem, and we learned that in like chapter 3 or something forever ago. And remember, that was when I warned you, from here on out, you're going to keep using these things, and it's going to come back to you. And here it
Yeah.
is.
So then they're like the same side interior,
So
so
it
they're equal
was-
to each other.
Right, so
Then-
angle A plus 102 should equal
180.
180. And then you can take away 102, right?
Mm-hmm. And then you have 78.
Yeah. So angle
And
A equals 78.
A and D are the same.
Yeah,
that's
so if I go
78.
back to like using the same highlighter, the star angle had 2 arcs in it, so those are congruent. So automatically D, is, so angle A is congruent to angle D. Therefore, my little dots, angle D equals 78 also. And what do you know about the 2 top base angles?
They're also equal to each other.
They
So
are.
then angle C equals 102.
Right, so if I put like a green arc in here and the green arc in here, so angle, sorry, not A. Angle B is congruent to angle C, therefore angle C equals 102, right? Measure up. Okay, hopefully not too difficult, but keeping in mind some of those properties of parallel lines and transversals is really, really helpful. Thinking about alternate interior angles, which would be like there and there, or same side interior angles, which we use there, or exterior. they will come back to haunt you or help you, whichever way you want to look at it.
On.
I think help. All right, example 2. So there's a fun picture if you're looking up at the Harbor Center Tower in Vancouver. I'm going to try to do a quick little sketch. It looks something like this, where I have concentric circles. I'm not going to draw it huge and super accurate, but something like this. It's a glass ceiling, and from here you have like almost like spokes that go out, right? You see that? So it's on page 321, if you care to look. It looks something like this, right? So it's all glass. There's little panes of glass, blah, blah, blah. Yay. I'm going to undo this in a second. So it would look really cool. I'd love a ceiling like that. I think it'd be really pretty. Let lots of sunlight in, right? But that's not what I care about at the moment. I care about a small section. So if I were to take like just a wedge of it, and it's part of a circle, so that side over there is curved, but it's so slightly curved. It's really made up of a bunch of straight edged pieces, and they're small enough to make it look curved. Kind of like a soccer ball, actually. So if I have something like this, and I have, where is it? Let's see, a dotted line to here, right there. So there's like almost like there'd be 2 panes of glass there. Yeah, right. And then
The lights reflecting.
I know it's hard to see at the moment. And I've got this, and then this, and each of these over on the right are cut in half also. So you end up adding more panes as you go. So really the one that we're gonna zero in on is this trapezoid here. That's the one that we're gonna like
And
zoom
this
in
one,
on.
right?
Yep, and the one right above it, right here. Okay, and there's a angle numbered in here, and that's angle 1. So it says the second ring, that's this part here, the second ring of the ceiling shown at the left is made from congruent isosceles trapezoids. In other words, this one right here with a heart is congruent to this one right here. So the idea of congruent any figures is that all the corresponding parts are congruent. That would still be the CPCTC, but without the T in there. Congruent parts of congruent figures are congruent.
So wouldn't the 4 at the right be all congruent too?
Yeah, these over here, yes, they should all be congruent also. Is the idea of how this thing was made. Okay, so then it says, where was I? Made from congruent isosceles trapezoids that create the illusion of circles. So it's not actually a circle. What are the measures of the base angles of these trapezoids? Each trapezoid is part of an isosceles triangle whose base angles are the acute base angles of the trapezoid. The isosceles triangle has a vertex angle up here, this isosceles triangle. So it's telling me this, that the sides are congruent, right? The isosceles triangle has a vertex angle that is half as large as an angle at the center of the ceiling. So you have to look at the picture and determine how many
Circles are
how many triangles. So in the picture, I'm gonna have you guys count while I draw this.
We're counting all of them?
In the center circle, yeah, put a mark in whichever one you start at, so you know where you're starting.
You can see marks in
You
this
have-
book already.
You have something that looks kind of like this, where it's all cut up, and that's the actual center of that glass dome top. And how many triangles have you figured it out are there?
There's
I got
20, so
20.
you do 360 divided by 20, and that would be
There's 20.
Okay, so we're gonna say there.
50? No, wait.
It doesn't look like it. My not drawn accurately. So there should be 20 triangles. Okay. So if I think about the single point in the center, let me change colors. There's a single point in the center, right? Go back to that color. There. Stop it. What is it doing to me? There's a single point there. How many degrees are there around a single point?
360.
Right,
So,
so-
it's 16.
360 degrees divided by 20 for each of the triangles is how many, Lily?
16.
Shouldn't be 16, because 36 divided by 2 is 18.
Oh.
right?
I did
So
that
this
wrong.
this should be 18. 18 degrees at the top of each of those, right?
Mhm.
So what?
Oh, 360.
Yeah, 360.
I wrote-
You wrote 300, right? Okay, so the measure of each of the angles of the center of the ceiling is 360 divided by 20, or 18 degrees. The measure of angle 1, then, they said is half of, right? Where was I reading it? Each trapezoid, no, where did I want to read? The isosceles triangle has a vertex angle that is half as large as an angle at the center of the ceiling. So that part here, angle 1,
It's half as large.
right?
So you do 18 times 2?
It's
Divide.
half as right. Angle 1 is 18 half over 2. 18 over 2, or 9 degrees. So you say angle 1 equals 9 degrees. Super tiny, right?
Mhm.
Okay, so how can I figure out the base angle down here?
Well, you already know that that one equals 9.
What? The one at the top, right? The vertex
Yeah.
angle equals 9, sure.
There's
How many degrees are there in a
92.
triangle?
180.
180 minus 9 divided by 2.
Okay, so because it's all three angles, so you could label these if you want to angle 2 and angle 3. So you could say angle 1 plus angle 2 plus angle 3 has to equal 180. Fill in the ones you know, which is only angle 1, plus angle 2 and angle 3 are congruent. So I could say 2 times the measure of angle 2, 180. And if I take away 9 to start solving, find my present, 2 measure of angle 2's equals 171.
So would the final answer be 95.5?
Close.
171 divided by 2.
Well,
Hold on.
oh wait.
Divided by 2. Yeah. 171 divided by 2.
Is 85.5.
There you go.
Oh, I thought it was the other
So
one.
measure of angle 2 equals 85.5. It should make sense that there's a 0.5 since that was an odd number that we divided by 2.
Mm-hmm.
Okay, so that's
Both
down
of
here, right? Okay, so this one is 85.5. So can we figure out that one now?
Yes. 180.
Okay, because our overall goal is to what? What's the overall goal?
Forget.
What are the measures of the base angles of the trapezoid? So you have an acute base angle and you have an obtuse base angle, right? One of them is less than 90, one is more than 90. Can you tell which one's which? I know it's hard in this
This
drawing.
one's more.
Nope. Other way around.
The other one's more.
The top
More
one. The
than
one that
90.
has the purple arrow
more
right
than
now.
90.
Yeah, is obtuse. It's more than 90.
Yeah.
So, but what do I know about here?
It's 180.
It's 180.
Right.
Minus.
Right, I'm going to get rid
85.
of this stuff here so I don't have to move my drawing. You guys have paper that you can just kind of keep moving on. Right?
So 94.5 is what the...
So 180, take away 85.5 is what should give you that, we'll call it angle 4 now, I guess. Angle 4. And what's 180? Take away 185.5.
94.5.
Mm-hmm. 94.5 equals measure of angle 4, which is also the same as, call that angle 5. And we still have angle 6 and angle 7 we need to figure out. How can we figure those out?
Well,
it's the same way we did
you
last
can make a
time.
big
Yeah.
triangle.
84.5
this line all the way
times
across.
2.
What are you saying, Lily?
Make a big triangle with all of this across, and then... Oh, no,
Wait,
that
you
doesn't
just
work.
add those up and add those up.
What do we know about
Why don't you just
Angle
say
4
85.5 plus itself?
an angle 6?
Angle.
What do you know about angle 4
are
and
they
angle 6?
corresponding?
Nope.
Like,
They,
So this and this are
they
parallel.
equal each other.
No, they don't
No.
equal each other.
they're
They all-
corresponding.
they're
so
supplementary.
180 minus
Stop it.
supplementary.
They're
that's what I'm-
supplementary, right?
that
Angle
seems
4 and
like the
angle
same.
6, that's what we just saw up here. Same side interior angles are
So
supplementary.
180 minus 94.5.
Didn't we, just do that a little bit ago? What should be the opposite of it? Because look what you just did there.
Mm-hmm.
You took away this to get that, so it should make sense that if you take away this, you should then get that one.
So
But try it if you want. So angle 6 should be 180 take away the 94. 94 point, not what I wanted to do. No, give me back my pencil. 94.5, which should then give you 85.5 degrees. Because angle 6 and angle 7 are congruent, so angle 7 also equals that. So did we find them all?
Yeah.
Yeah.
Okay. You sound so excited.
Yeah, you
How
found
is the
out.
Good
How
job.
is
There
the
you go.
same?
What's that?
Oh, I guess that would make sense.
So another thing that I was thinking of
I should
here.
have just drawn this thing over here like this.
Let me
Would've
go back
gotten
and
it really
highlight
easy.
something on this real quick for you. If these lines are parallel right here, right? They're parallel, right? And then this is your transversal. Angle 6 and angle 3 are what kind of angles?
Or no, they're equal to each other. Corresponding.
They're corresponding. Corresponding angles are congruent. So that was another way you could have looked at it too. Lots of fun ways to look at this stuff.
Yay.
I know, y'all think I'm nuts. Maybe I am. Just not willing to admit it. All right, so another theorem for you here. The diagonals of an isosceles trapezoid are congruent. The diagonals of an isosceles trapezoid are congruent. So I'm gonna pull out my little diagram that we've been adding to, and I'm gonna add to it. So find your isosceles trapezoid, you can draw
I
in
left that book at home.
this and this. They're congruent, so I can highlight this in this and then say that they are congruent. Right?
Mm-hmm.
So we learned that. And then we also learned a little bit ago that I need to change the color again. The base angles are congruent, right? So we can add that in there. Base angles are congruent. Diagonals are congruent, base angles are congruent.
Mm-hmm. Oh no, proof. We can just skip it.
Yeah,
No,
we can.
it's really good practice because some of you all are still not very comfortable doing proofs on your own. Okay, so proof. Let's try it because I need to change this. Right. So given. Here it is. Given isosceles trapezoid. A, B, C, D with A, B congruent to D, C. So we're told that it's an isosceles trapezoid. So I'm going to do a quick sketch of an isosceles trapezoid here. And we can put in what we know about trapezoids in general. We know that the top and bottom are parallel. We know that the legs are congruent. It's not given, but that's in the definition of an isosceles triangle, right? Trapezoid.
Mm-hmm.
So and I'm going to label it, sorry. A, B, C, and D. And then we have some diagonals drawn in. There and there.
Does it say to do that?
Well, because, sorry, I didn't write the prove part. The prove part is to prove that they are congruent. So prove segment AC is congruent to segment DB. Okay? AC is one of the diagonals, and then BD is, of course, the other diagonal. So if I need to prove that those two are congruent, any ideas on what I can do here? What do we know about this?
Well, I mean, we're proving it, so we already know that it's congruent. So
Well, we know this triangle here, A, B, this one, and D, C are congruent.
Why do you know that?
Because these angles and that angle are congruent.
Okay, so what
And
Annalise is saying is we know that base angles in a trapezoid are congruent. I'm talking through before I write stuff out. We know the base angles are congruent. So then you're saying that what?
that these two triangles are congruent.
Triangle. I'm going to highlight two triangles because it's kind of hard sometimes to see the triangle we're talking about. I think you're saying
Because of angles.
name
at
it with the
angles.
vertices. Triangle what?
Triangle A, B,
Midpoint.
midpoint.
8B midpoint.
This dot right here, she's saying.
Oh, here. Okay. So here,
Mm-hmm.
what are you going to do with that?
Not really.
With-
midpoint.
How can you prove those are congruent?
With DC. What are you saying?
I'm not sure you can prove those. And then this one,
Yeah.
not sure you can prove them congruent. You might be able to, but it'd be pretty tricky.
But you have that one and then you have that angle.
Well, I
and that
don't
angle.
have this angle. How do I have that angle? I have the whole angle,
Yeah.
but I don't have the
What are we
part.
trying to prove? Oh, we're trying to prove those two lines. Never mind.
Yeah.
Yeah, whatever.
I
Let,
don't
let
think
me
that's gonna
let me
help.
get rid of well, I want to get rid of the highlighter stuff. Oh, undo that because I don't want to. There we go. That's what I want to undo. I want to erase that. Okay.
Wait, what are we trying to prove? I'm still
What?
confused.
The two lines.
The two
that
lines
you
are
drew from.
congruent.
So
Oh,
I'm
I
trying to prove this line and this line are congruent, right? So it's given that it's a trapezoid, an isosceles trapezoid, right? So it's also given that AB, right here, is congruent to DC. That was given.
Yeah.
Okay.
Well, wouldn't angle A and angle B be congruent too? Like
No.
angles congruent?
No.
They are though, right? Base
Yeah,
angles are
they're
congruent. So
quadrilateral.
because
It's
so
saying A and B.
so you could say statement. I'm not gonna. I'm just gonna do it as a paragraph proof. I'm not gonna do the statement reason thing.
Oh, A
Okay.
and
So
B.
it's given that AB. So that's your reason first given, and your statement is AB is congruent to DC. Those are the two legs.
Mm-hmm.
So that's a statement and a reason within there.
Yeah.
And then you say because the base angles of a trapezoid are congruent. So you could then say angle A, B, C. Quick reminder what that is for some that are still working on how to name angles. That's angle A, B, C. That's this part in here. That's how I'm naming it. Angle ABC, sorry, go back to this. Angle ABC is congruent to angle DCB. So the two arced angles. Because, so I'm just putting that in parentheses, like that's what I'm showing you. So that's the whole, because base angles are of an isosceles trapezoid are congruent. So that's the two arcs, and then I'm gonna did one arc in the top because both sets of base angles are congruent. Because of that, I can say
Angle BAD is congruent to angle CDA.
what? Well, the ones I just said, this right here, that right there. I'm gonna say it again. Because base angles of an isosceles trapezoid are congruent, angle ABC is congruent to angle DCB. Do you see what I'm saying?
Yeah, I get that.
Okay.
I'm saying I'm going to the other.
So I said
So you
why.
have the
I did
lines.
the reason, then the statement again, because it's a paragraph proof. It's a little different. Like you say it oppositely. So it's given that it's isosceles trapezoid because it's the base angles are congruent. These angles are congruent. Great. Then I can also say by the reflexive property, this segment is congruent to itself, right?
How does that help you?
We'll see. So, by the reflexive, I wrote that wrong, aren't we? The reflexive property, BA is congruent, BC. BC is congruent to CB, right?
Mm-hmm.
Then So if I look at a couple of triangles here, I'm gonna pick a different color highlighter, but I need to change something on here of like how light it is. There we go. Okay, so if I look at this triangle right here, I have a side and an angle and a side.
Mm.
And then if I go and look at this triangle, I have a side and an angle and a side.
We did one of these in a challenge.
We
thing.
did, I know. So because we have all that,
And then you can prove by CBC to see that those two are the same.
the two, I can prove the two triangles are congruent that I just highlighted. Right? So by the reflexive property, that's congruent. Then triangle ACB is congruent to triangle. So I went from A to C, go away, C to B. So A was the base angle at the top. So I need to say D is the corresponding part to B to C. Those two triangles are congruent. Now wait a minute, our whole goal
A's.
was to prove this line here is congruent to this line here, making it
Do
super
that with
messy.
CBC to C.
Exactly. So now I can get to my proof statement. So I can say it now. I can say, therefore, AC is congruent to DB by CPCTC. So it's good to go through proofs, especially with assistance, so that you can start to figure out how to do it on your own. Okay, so then one more theorem and one more example. What?
There's another proof, isn't there?
There is, but I might just talk through it and not write it all out. We'll see. We'll see. Okay, so the next theorem is that the diagonals of a kite are perpendicular. The diagonals. Why can I not spell today?
Nothing's
Spell diagonals.
spelled in mine.
DIAGONALS. Diagonals of a kite are congruent. Oh, sorry, not congruent. Perpendicular. Definitely not perpendicular. Or sorry, congruent.
Congruent.
They are perpendicular. And I'm putting the symbol there as well as the word in parentheses just so you all get used to that symbol. Okay, so quick, just like look at it, watch. You don't need to write this, but understand the best you can. There's my pathetic kite. So if I have S, no, not S there. And I'll connect this. So this is S, T, W, R, in here, and oh my gosh, I drew this so badly. Hold on. This is, come on. Really, really bad. Let's try that again, really quickly. Okay, so there's my kite. My kite, remember, has consecutive sides that are congruent. That's what makes it a kite, right? And then if I have the diagonals, the lines that connect the opposite vertices, they're saying that this is perpendicular. If I look real quick at this half here, right? I have an isosceles triangle. Therefore, I have
Those base angles are the
the
same.
base angles are the same right here, right?
Yeah.
And then I also have this is congruent to itself, right? And what else do I know?
These lines down here are too.
So we know what's that?
Base
By
angles from the bottom.
bisecting, the definition of bisecting lines.
We don't know that they bisect each other.
Oh, I thought that was what these lines were. Oh, never mind.
The diagonals, no. So, let's see, what am I looking for?
Right now you
the-
have
what?
side, and angle.
Well, so if I'm given also RS, I didn't label it again. Why do I keep doing that?
Oh, I know you have
S.
angle side because you have the right angle.
Where? Yeah,
There's
yeah,
no
yeah.
bad words.
Yes, right. I have, what is wrong with my thing? It's like freaking out on me. So yeah, Hannah, you're saying I have angle, side. I have two congruent triangles. These have to be perpendicular to each other. there's, let's see, the whole converse of the perpendicular bisector theorem. So if I have an isosceles triangle, then I know that if I drop a line down here, then it has to be the perpendicular bisector. And it's true of same thing, but flipped down here. I'm not going to walk through the whole proof. You can if you want to. It's in your book. Read through it. Hopefully it makes a little sense. I'm going to keep going on to example 3 for the moment, okay? I know, you guys. Example 3. Find the measure of angle 1, measure of angle 2, and the measure of angle 3 in the kite. Reading the directions is pretty critical so that you know what you're looking at, because you cannot always go on appearances. So if I have my kite, trying to learn to draw it accurately. Here and here, and it's labeled A,
That's the
B,
worst
C, D. C? I know. A, B, C, D.
Oh wait, we're not trying this one anyway.
I have angle 1, angle 2, and angle 3 over here. And they're giving me that one inside there is 32 degrees. And then just for the sake of reiterating, these two lines are congruent, and that's congruent. Okay, so now what?
Well, you know that angle 1 is a right angle.
Okay, so the measure of angle 1 equals 90 degrees. That's pretty easy. So how can I find any of the other ones?
You add 32 plus 90, and you take it away from 180.
Okay, but do it as a whole algebraic statement.
So measure of angle B plus the measure of angle
B.
like
Oh,
CBA.
yeah, okay, so yeah, sure. So measure of angle. Oh, I didn't put a. I didn't. Okay, so we're just gonna say angle. 32 degrees, because it's not labeled in the center. Plus measure of angle 1 plus measure of angle 2 equals 180, right? Is that what you're trying to get at?
Oh,
Okay.
you meant, okay, 30.
And we knew 1, we already figured that out, so we could say 32 plus 90 plus measure of angle 2 equals 180. So if I take away the combination of the two of these, the combination of the two of those is
122.
good. So if I take away 122 from both sides,
Then you have 158.
shouldn't be 100.
No, 58.
58. Okay. So I found measure of angle 2. How can you find the measure of angle 3?
Which one's 3 again? I like don't have that in the book.
It's up in your book.
Oh,
Should that be the same as 32?
Yeah.
Why should it be the same as 32?
Because it's an
Because they're
isosceles.
reflexive and it's an isosceles.
It's an isosceles triangle,
Split in
sure.
half.
Right, split in half.
Because you know
Because
that's 90
this
there, so it
angle
has to be
down here.
perpendicular.
Right, angle 2 and this angle over here by A are congruent because of the top half is an isosceles triangle. You have right angles in the middle. So you have angle, side. So these two congruent triangles are, sorry, these two littler triangles are congruent. So you have CPC, saying that this angle and this angle are congruent. So measure of angle 3 equals 32 also. Can you find, this is not part of your question, I'm asking you, can we figure out any of the angles down here?
Yes.
Yeah.
How?
Oh, we already know
You
90.
already know this is 90 there.
Okay, so you know 90.
And they're isosceles triangles.
So the big thing, if I
The bases
highlight
are
it,
the same.
the whole, come
So
on.
all the other sides,
This is an isosceles triangle.
yeah.
Okay, so how can I find, which angles do you want to attack trying to find first?
Bottom
C and
base.
A.
C and A. Okay, so here and here, how can I find those?
Well,
Give me a variable for, do you know the angle here?
No.
Can we call it X?
Yeah.
Okay, therefore this is X also, right?
Mhm.
Yes.
Okay. So what can I say?
Well, wouldn't C the like angle? Oh wait, it's D.
It's
Angle
tricky.
D and angle B be equal to each other?
Angle, where is it? Sorry.
Top
No.
and bottom?
No.
I don't
No,
think
B and D are not necessarily congruent to each other.
Okay.
Did we know this one in here?
Yeah.
What is it?
58.
58. What's this one over here then?
58.
Okay. And do we know the total angle up here?
Yeah.
What is it?
It's
Oh.
oh wait, 30.
64.
64. So before we can find these purple X angles,
can find what this whole line would be.
Not yet. Can we figure out this one? That angle.
Yeah.
How?
I know you can, but I don't know how.
How many sides are there on this figure?
There's 4.
Okay,
3.
there's 4 total if I'm looking at the green
Oh, you're
figure,
looking
right?
at
The whole thing.
Okay,
So the whole thing, there's 4 sides, right?
Mm-hmm.
Do you remember this formula?
Yeah, but squared.
N minus 2 times 180.
Yeah, I forgot
That
about
can tell you
that.
how many degrees there are in the whole thing.
Mm-hmm.
We know what's here, this part. We know what's here. We know that this is X and this is X.
Mm-hmm.
Can we figure out the remaining parts somehow? How?
Mm-hmm.
You put in.
I actually don't know that we can.
Oh, really?
I don't know.
You put
We
in
should be
58.
able to.
58 take away 2.
58.
Oh, wait, no. What if,
4. For
Yeah.
this thing here?
Yeah.
Yeah, there's 4 sides. So it's 4 take away 2 times 180, which is 2 times 180, which is 360.
360.
So every 4-sided figure has 360 degrees.
Mhm.
There's 2 triangles in a 4-sided figure.
mm-hmm.
Going from one vertex.
Yeah, that's
remember
how
that?
I always did. I never did that formula thing. I just
Oh,
found
just
the
find how many triangles
and
there were?
then
Yeah, okay.
multiplied it.
So there's 360 degrees in this whole thing.
Mm-hmm.
We can figure out what we have left to work with based on what's already taken up, right?
Yeah.
Okay, so we already have,
360 minus 85 times 2 and 64.
okay, so we're gonna take away this whole thing of 2 times 58 and 64. I don't need that. I need a bracket. So it's a 360 take away all of this. Let me figure out what all of that is. 58 times 2 is 116.
116.
Plus 64. 180.
180.
Oh, should make sense because we took away the whole top triangle, right?
Yeah. So you're
So,
left with the 180.
okay. So 180 is what's left,
Is the purple triangle.
which should make sense because the purple triangle should be that. So, that really didn't get us very far either, did it?
No. You already
no,
knew that.
I know. I don't know if we can figure this out. I don't think you can because this would be a variable here also. Yeah, without any more information, we can't figure it out. Sorry.
I thought
Could've
we
been
were
fun.
going to be able to find what x equaled.
I was.
I thought you were going to be able to, because I thought you were going to be able to extend this line here and then find what this angle was by
Where?
this. Something.
Extend which line?
This line. Extend that line.
If I extend this line,
You'd be able to find what this angle is because it's that
No.
one or something.
No, it's
No,
not.
it's not.
Not necessarily.
What are those?
Because this line and this line are not necessarily parallel.
Oh,
If
they're
you-
not.
No.
I thought they were.
No, they're not. Okay, well,
Oh,
it was
then
kind
you
of fun at
can't.
least thinking about what we might be able to do. Because you're going to have fun doing all those kinds of things in
This is actually really like an easier.
an easy section. I hope so. All right,
Cool.
so that is it for the lesson. But it was.
not really crazy. This is fun to do. I just don't like
I
doing
know.
the proofs.
Well, sure. Okay. Anyways, thanks for joining us.
We're gonna be sad.